In this video, we are going to learn about the partial fractions, which involve non-repeating linear factors in the denominator. This is the learning outcome. A fraction can be expressed or decomposed as the sum of two or more separate proper fractions. This is known as partial fractions. Proper fraction is when the degree of numerator is less than the degree of denominator, like the example below. There are three forms of partial fractions. The first one is with non-repeating linear factors in the denominator. The second one is with repeating linear factor in the denominator. And the third one is with quadratic factors that cannot be factorized in the denominator. The first form of partial fraction is with non-repeating linear factors in the denominator. If fx over gx is a proper fraction and the denominator has a non-repeating linear factors, then the fraction can be expressed as this one. The example are like this. When the denominator is a multiplication of two factors, then the fraction is decomposed as a sum of two partial fractions. If there are three factors in the denominator, then the fraction is decomposed as a sum of three partial fractions. Question 1 is we want to express this equation in its partial fractions form. Since the denominator has two linear factors, so the fraction can be decomposed as the sum of two partial fractions, where the denominators are x minus 1 and x plus 2. Every time the denominators are linear factors, then the numerator must be a constant, and we usually use capital letter A and B. Now our aim is to find the values of A and B. So what we are going to do now is to multiply the whole equation with x minus 1, x plus 2, which is the denominator of the fraction. We multiply with the fraction on the left side first. The denominator is cancelled, which leave only 2x plus 3 on the left side. When we multiply this fraction with this expression, x minus 1 will be cancelled and leave a multiplied by x plus 2. Now we multiply this fraction with this expression. X plus 2 is cancelled and leave b multiplied by x minus 1. We use the substitution method to find the values of a and b. The easiest way is by substitute the value of x when the linear factor is 0. So let's try substitute x equals to 1, which comes from the linear factor x minus 1. We notice that this part disappears because 1 minus 1 is equals to 0. So we get the answer for A. After that, substitute the other value which comes from the factor x plus 2. This part disappears and we get the value for B. Now substitute the values of A and B into the partial fraction. Since both values are in fraction form, so we can simplify it become like this, where the numerators 5 and 1 are written on top and the denominator written at the bottom. For this example, the denominator has three linear factors, so we can break it down to three partial fractions. Now we want to find the values of A, B, and C. So we multiply the whole equation with the denominator x plus 1 to x minus 1. We will multiply these two first, which will cancel the denominator and leave 5x plus 1. Now, when we multiply this fraction with this expression, x is cancelled and leave a multiplied by x plus 1 to x minus 1. Then multiply this fraction with this expression will cancel the x plus 1 and leave b multiplied by x multiplied by 2x minus 1. And the last one is multiply this fraction with this one will cancel the 2x minus 1 and leave c multiplied by x multiplied by x plus 1. Now we have an equation with unknown a, b, and c. We can solve it by substitution method. We substitute x equals to 0 first, which come from the linear factor x. Since these two are multiplied by 0, so these two parts disappear, and we will get the value of a. Next, we substitute x equals to negative 1. This comes from the linear factor x plus 1. This part disappears, so we will get the value for b. And now substitute x equals to 1 over 2 into the equation, and we get the value for c. After that, substitute all the values of a, b, and c into the partial fraction. For this question, the denominator of this fraction is in general form, but can be factorized to x minus 1, x plus 1. So, the fraction is decomposed as a sum of two partial fractions. Multiply the whole equation with x minus 2, x plus 1. Then multiply x minus 2, x plus 1 with every fraction in the equation. The left side will be equals to 3. The second fraction leave a multiplied by x plus 1. And the last one leaves b multiplied by x minus 2. Now solve for a and b by using the substitution method. We substitute x equals to negative 1 first, and we get the value for b. After that, substitute x equals to 2, and we get the answer for a. Now state the final answer by substitute the value of a and b into the partial fraction. Please submit this exercise before class ended. Thank you.